All right, hi guys. So today we're going to do a little review on quantum numbers. So you should have watched the notes over quantum numbers already and taken the notes over that. So this is going to be a review and hopefully trying to explain the concepts a little bit more in detail because I know quantum numbers are a little on the confusing side. So quantum numbers, so first off, we can't pinpoint exactly where an electron is in an atom. With the Heisenberg uncertainty principle, it says you can never know exactly where any electron is at any given point. But we use quantum numbers to describe where we think an electron might be. So those are going to be kind of where they're most likely to be found. And so that's what we're going to use quantum numbers for. So there's four main quantum numbers. So we're going to go through all four of them. The first one is the principal quantum number m. This just represents the energy levels or the distance from the nucleus. So you have, for the 118 elements we have in existence today, there we can get up to energy level 7. So we have n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, n equals 6, and n equals 7. So we have 7 energy levels as of right now with the 118 elements that are in existence today. You can see here in this diagram I've shown you, here's n equals 1. That's the first energy level closest to the nucleus. Then 2 is a little further away. 3 is even further. 4 is further. Then if we were to continue, you'd have 5, 6, and 7. And they just get further and further away from the nucleus. The larger the number, the further the energy level is from the nucleus. So an electron in energy level 4, for instance, is further from the nucleus than energy level 1. And the further from the nucleus, the more energy those electrons have in order to keep them moving around the nucleus at that particular energy level. All right, so our second quantum number is the orbital quantum number, which represents the shape of the orbitals or the subshells. So we have 4 of them. We have the S, the P, the D, and the F. They have numbers associated with them. S is 0, P is 1, D is 2, and F is 3. But because when we're describing all of these electrons, if we're constantly using numbers for everything, it gets a little confusing. So we're going to use letters. So S is a sphere, P is a peanut, D is a double peanut, and F is the flower shape. And so within each energy level, you are going to find these subshells. So let me kind of go through and how do those relate to each other. So in energy level 1, it has one subshell. The only subshell energy level 1 has is the S subshell. So all you're going to find in energy level 1 is that S subshell. In energy level 2, you're going to find the S subshell and the P subshell. All energy levels are going to have the S subshell in them. So in energy level 2, you're going to find the S and the P there. So you have your S and your P. In energy level 3, you're going to find the S, the P, and the D. So here we have energy level 3. So I'm going to draw in my S, my P, and my D. A little iffy on how my drawing looks, but that's okay. And then in energy level 4, we're going to have all 4 of our current subshells. So we have S, P, D, and F. So I'm going to draw those in as well. So you have your S, your P, your D, and then my F looks even always iffier. There you go. There's my F. So you have all 4 subshells. Energy levels 5, 6, and 7 are all also going to have S, P, D, and F. So all of them will. So energy levels 5, 6, and 7 will have S, P, D, and F as well. So theoretically, we could actually have more subshells in energy levels 5, 6, and 7. But due to the fact that we don't have any elements that are big enough to have those subshells, we only get up to subshell F. So energy levels 5, 6, and 7 are going to have S, P, D, and F as well. So that's kind of how you want to think about those. So you have your S in the energy level 1, S and P in 2, S, P, D in 3, and S, P, D, and F in 4. All right, our next quantum number is the magnetic quantum number. So each of those subshells has so many what are called orientations, which is how they form on the axis. And so hopefully when you watch the video on the notes, I kind of showed you what those looked like. But the S subshell has only one orientation. The P subshell has 3 orientations. The D subshell has 5 orientations, and the F subshell has 7. Every individual orientation can hold up to a maximum of 2 electrons. Electrons happen to like to pair up with one another. They like to be together with a friend. And so they just like one other friend. And so each orientation can hold up to 2 electrons. So subshell 1 has one, or I'm sorry, S subshell has 1 orientation. So if every orientation can hold up to 2 electrons, there's 1 orientation, we have a maximum of 2 electrons. The P subshell has 3 orientations possible. So each of those 3 orientations can hold 2 electrons. So 2, 4, 6 electrons. So the P subshell can hold up to 6 electrons. The D subshell has 5 orientations. Each of those can hold 2. So we have 2, 4, 6, 8, 10. So the D subshell can hold up to 10 electrons. And then we have the F subshell, which has 7 orientations. So each one can hold 2, 4, 6, 8, 10, 12, 14. So the F subshell can hold up to 14 electrons. So that's how that works. So each orientation, that's just how many electrons fit in there. No real reason why. That's just how what the orientations hold and how many electrons can go. So let's kind of put that all together in terms of how does that look for energy levels. So the energy level 1 has just the S subshell. The S subshell holds up to 2 electrons. So we just said that, the S subshell right there, S subshell holds 2 electrons. So energy level 1 just has the S subshell. The S subshell holds 2 electrons. So energy level 1 can only hold a maximum of 2 electrons. So the energy level 2 has an S subshell and a P subshell. Well, we just said the S subshell holds 2 electrons. We come back up here. The P subshell holds 6 electrons. So if the S subshell holds 2 electrons and the P holds 6, and we have an S and a P, the energy level 2 can hold up to 8 electrons. That's an energy level 2. I don't look at energy level 1. This is just an energy level 2. Energy level 2 can hold up to 8 electrons. So energy level 3 has an S subshell, and we just said that holds 2 electrons. A P subshell, which we said holds 6 electrons. And then it also has a D subshell. If we come back up here, the D subshell has 10 electrons. So the D subshell can hold up to 10 electrons. So in just the third energy level, we have the S, the P, and the D. So 2 plus 6 is 8 plus 10. We can hold up to a maximum of 18 electrons. Then energy level 4 has the S subshell, which holds 2 electrons, the P subshell, which holds 6 electrons, the D subshell, which holds 10 electrons, and the F subshell. If we come back up here, we can see it holds 14 electrons. So the F subshell is going to hold 14 electrons. So if we add those all together, 14 plus 10 is 24, plus 6 is 30, plus 2 is 32. So energy level 4 can hold up to 32 electrons. All right, and then we have our last quantum number, which is the spin quantum number. So electrons can spin one of 2 ways. They can either spin in a clockwise or a counterclockwise position. And they're going to be represented by a positive 1/2 for clockwise and a negative 1/2 for counterclockwise. And then the electrons actually pair. So you have the clockwise and the counterclockwise, and those electrons are going to pair up like that. So either a clockwise or a counterclockwise spin, a plus 1/2 or a minus 1/2, and the plus 1/2 and the minus 1/2 will pair up. So when we represent electrons, and we'll kind of do this as we move forward, this is kind of going to bridge us into the next section. We're going to represent electrons with either a up arrow or a down arrow. The up arrow represents a positive 1/2 spin, and the down arrow represents a negative 1/2 spin. They always have to pair up with a positive 1/2 and a negative 1/2. So we're going to show the orientations with either like a blank line, so you can see that right there, or a box. And then we would put our electrons in there, because remember, each orientation can hold up to 2 electrons. So then I can put my electrons in here like so. So when they pair up, that's how you would see them. Okay, so that's going to kind of bring us into the next section, which is orbital notation. But that gives you a nice brief review of quantum numbers.